Hello and good morning to our distinguished guests in the Daniel Biotech offices. I'm very pleased to present to you Pierre Videling, our column expert, column packing expert, and chromatography expert. We brought especially for this event, for this seminar, to introduce to you the advanced column packing techniques and our most advanced column, the AxiChrom 600. Pierre has many years of experience in column packing, chromatography, industrial column packing, and I've been knowing Pierre for years, and he will teach us a few important basics in industrial column chromatography, tips and tricks, and all the technology. It's a very exciting technology. Pierre, please.
Thank you, Slurry. Thank you very much for your help and all the work you did to prepare that activity. And thank you also to Luli for the excellent work he's doing as usual. So we are going to talk about the latest column technology that you can get, which is the AxiChrom. The AxiChrom is a closed column which is automatically driven by a unicorn or by the master that you can see here. The good point of having the column with the unicorn is that you can have a full report of your packing, including column testing, which means that in your documentation you can now implement the packing with the value of compression ratio, volume of media loaded, and a final HTTP test that will qualify your column. So it's a big step forward for qualification. The second good interesting point about that column is that it is fully automated, which means that anyone, even with you can take someone in the streets, bring him in front of the computer and have him pack the column, because you just have to follow the instruction. This is something we will show you on the unicorn screen. Finally, you can see that the connections are very few. There are 4 connections. There are 2 for the process, one on the top, one on the bottom, one on the top, and then 2 connections for the media. And that's it. For the rest of the packing, everything is done with the packing engine that you can see here. So there is no more flow to pack the column. It's only actual compression. Why is that? Because the technology of the column is made according to the media. So if you look at the past, you used to have some Cefadex, Cefacryl media with very low flow rates, and then we were using the BPG. It was designed for that kind of BPSS column, for the oldest one. That was the kind of column we were having for this media. Then came the fast flow media. So the fast flow media, you are using the ChromaFlow, because it's a media that goes to 500 centimeters per hour, so you can flow pack it into a ChromaFlow. But when it comes to the new media, the one which are running at 1000 centimeters per hour, you cannot flow pack them anymore, because the pumps are not powerful enough, and it's getting dangerous, because you have several cubic meters per hour when you have to pack such a media, and you can have a problem very, very quickly. Also, the ChromaFlow, the design of the ChromaFlow is different, because it's a conical column. So the top and bottom parts of the column have conical ends. So if you use, for example, other media from competitions like CHT or like Procep or like Fractogel, this media will not be well packed into ChromaFlow's type column because of the rigidity of the beads. So one design of that column is that it has flat surface. So it's a universal column. Whatever kind of media you are using, it can be packed in AxiChrom as long as you know its compression ratio. And that's it. That's the only important things you need to know, is the compression ratio of the media. What we are going to do now is that we are going to set the method into the unicorn. So you will see how simple it is to write this method. Shai, if you want to get closer, I will show you how to write down the method through the unicorn. So here you just start as if you would like to write a new method. So you go on File and New Method. Here you will select the method wizard and go to OK. When you do that, you have that screen that does appear. That screen is dedicated for the AxiChrom, and it's a wizard that helps you to write down your method. So here you have several things that you can do. You can do a column packing. You can do a packing test, so HTTP testing. You can prime the column before you do your packing to remove all the air from the column, and you can unpack the column. Here we are going to do a column packing with packing test. So we are going to pack the column and test the column after, so you will have a validation of the column online. The column we are using here is a 600 by 300. So you have a screen where you choose the column that you want, okay? To let you know that you can go up to 2 meters with AxiChrom. And you start at 5 centimeters, you go to 2 meters with the exactly same technology. So that is very interesting for your process when you are upscaling. So we take the 600 by 300, okay? And we want to take the media that correspond. So it's the Q Cepharos XL, correct? Q Cepharos XL, thank you. So here you have all the information that you need for the packing. Then you go next. Our target bed height today will be 19 centimeters. So we enter the target bed height. And we will get the mobile phase for rinsing and for column testing through inlet A1. So you can choose whatever you want as inlet. So you can choose inlet A1, A2, you have all the ones that you want. The inner diameter is, how much is your inner diameter of the pipe?
Of the tube?
Of the tube.
19 millimeters.
19 millimeters, so we enter here the diameter of the pipe and the length, which is 4 meters.
Yes.
4 meters. This way, we have all the information, and the system will take in consideration the void volume of the piping. So we can go next. Here, we want to use the default packing factor for that media, so it's 1.1. And we are going to get some tolerance. So that is you to decide, but usually we put 2 centimeters of tolerance to be sure that we are in the right dimension. So we are 19, we set 21 and 17. Usually we will be much, much closer to 19, but this is for security reasons. Okay, now we have to do the only thing which is going to be manual. We have to measure the slurry concentration. So, sorry, if you can mix the slurry. For that, we have a tool. Sorry, I will get out the screen. We have a tool that you can, it's a slurry concentration kit. This is something that is very, very useful to determine the slurry concentration in a very quick action. So, this slurry concentration kit is nothing else than a small column that you can see here with a syringe, and we will simulate the bed stabilization of the media. Sorry, is the media ready? Or?
In a half a minute.
So we have to wait for the media to be settled. So it's going to take 5 to 10 minutes for it.
What I'm doing manually now can be done by an automatic resin mixer.
Yes. We are selling a slurry tank that can be connected also to the ACTA process, and that will be driven by Unicorn also. So you can have a full automated solution with the packing tank, the ACTA process, the AxiChrom column.
I think it's uniform now.
It's good now?
Yes,
Okay.
it's uniform. You can
So-
take.
Okay, so this is the only things you really need to be careful when you are packing an AxiChrom column. It's the slurry concentration, because the slurry concentration will be the things that at the end will give you your packing heights. So if you are not right with the slurry concentration, at the end you may not be right with the bed height. It's the only thing you have to be careful about. So I'm taking a sample of slurry now. And I will be loading the slurry into the kit for testing. So if you come here, you can see that there are some graduation on the kit, and you have to be at 10 very precisely. So here you can see, you can read 10. So it means that my reading will be
Give me the pipette.
will be
Pipette?
I will empty it.
Okay. Okay.
And now you put the top adapter of the testing kit into the column itself. And now we will test the slurry concentration. So this is the only step you have to be careful, and you should have a drop a second, and you will see the bed forming. If you want, if you want to get closer, if you look at the bed on the testing, you see that the density of the bed is increasing, and that will give you at the end your slurry concentration kit. The slurry concentration. So we can see, if you look here, if you read, there is a kind of edge on the side of the slurry concentration kit, and we can see that we have a slurry concentration of 45%. So that's the value we will get into the system. For security matters, we will do a second test to check the second value. If you can remix the media, please. So once more we do the same rule. We load up to 10. And we follow the same method. So as you can see, that tool is very important to determine the slurry concentration kit. It's also very fast, and the good thing is that it works with any media. So you can see the bed stabilizing itself and compressing. And we will try to check that we get the same value as before. Okay, so what we are seeing here is that we have a slurry concentration that is lower. It's only 43, so it means that we need to redo a test because it's a mixing. So you need to mix it more. We don't have the same slurry concentration, so we have to redo a third test and to check the right value. Okay? That's the only important things that you have to do with AxiChrom. I think you're not homogeneous.
Okay, only to give it 2 minutes constant stirring.
Yes. So we're going to mix a little bit more the media to be sure that it's very homogeneous. That's where it is a big advantage to have a slurry tank, because then you have something that you're sure it's a way good mixing. In that case, it's we are depending on someone mixing the media, and then we have to be sure that it is well done. So that's the reason why it's good to go to an automated solution like we are going with AxiChrom. Sorry, what do you think?
I think it's quite homogeneous now.
Good. So let's do a third test. Okay, so we are ending with a final slurry concentration of 43. So it means that the first value of 45 was wrong, and the final value to recover is 43. So we will enter 43 into the packing master. We are going back to our unicorn method editor, and here we are entering 43, which is the value. Now we are going to talk about the test itself. So it's asking you for a calibration volume before the test. In order to go fast, normally it should be a minimum of 2 column volume. But because we want to go a little bit faster, we put 1.5. It's asking you if you want to use default velocity. So he's telling you 100, we will go 60 centimeters per hour, and use default velocity for packing test. So that will be 30 centimeters per hour, and we will do a test in downflow mode. We are getting the sample through inlet A2, so we are connecting inlet A2 for the sample. When you have done that, you have a recipe that appears on the screen when you find all the information that you are looking for. What I see here is that it's giving you a okay, and we are checking the value, and we found that everything is straightforward. It gives you the minimum volume of buffer to prepare. So on Mobil phase 1, you need to have 188 liters, and in inlet A2, you need to have 9 liters of concentration for the testing solution. So you can double check that everything is connected, and then after we can start the packing. It is possible to print the recipe here and to put it into your record if you want, knowing that at the end you will have a report anyway. So you want to save your method now. And we name it AxiChrom packing. Then you go to your system control, and then you open the method. That you find in your file. So AxiChrom packing 19QXL. You click on it, and then you will have some variable that you are able to change if you want to change anything. So here you have your spherical volume of the column, 53 liters, the pressure limit of the column, the hose diameter, its length, you can change this value, the slurry concentration, it's still time to change it if you want, the inlet for rinsing for Mobil phase, and the system wash volume, and so on. So it's all values that you can change into your report. Now here you have the method by itself, so it gives you all the information you are looking at, your bed height, your compression ratio, the minimum bed height, the maximum bed height, your packing velocity, and all the information that you need to have through your testing. So here you can enter your serial number for the column and your medium node number if you want to use the method as a documentation for your process. So when we will be pressing start, it will start the packing. So I'm double checking the piping to be sure that we are okay. Here we have the pressure gauge that will control the packing. I will explain you later on how it works. And here we have all the line connecting to the column. This is open, this is closed, so we can go. So if you want to come here, you can see, if you want to come here, please, Shai. You can see now that the master is in remote control. It means it is controlled by the ACTA system through the Unicorn method. So what it's doing now, it's priming the line through A1 and priming the line in order to be sure that we don't have any air bubble. This is something very, very classical. Keep on mixing the media, please. Yes. You should never stop mixing the media. Here you can have some information that you can look at. You have your adapter position over here, your adapter speed, and if you look here, you look at your adapter position, adapter speed, and packing factor. So you will find on the screen all the information that are linked to the packing by itself. You can have the time to packing factor, the packing factor, and the media valve position, which are all information that after you will find into your report and that you are can read here. So all the information of the column are now on the screen. So we are waiting for the priming of the line, and as soon as this is done, it will start to load the media from the slurry tank. So he's asking you, open the slurry tank valve and then press continue. As soon as we do that, it will open the bottom valve of the media on the column, and it will suck media in. So be sure that the pipe is at the bottom of the tank and that everything is well mixed.
Yes, yes.
Is it okay, sorry?
Yes, it's at the bottom.
So now you can see that the media valve is open and the top adapter is moving up at 300 centimeters per hour. So if you come here, you will see the media. If you come closer, Shai, you can see the media to be loaded into the column. What is interesting is that we are not using any pump. We are just using the top adapter as a syringe. So it's sucking in the media, which means that if you have, for example, a very fragile media, like a CHT or like a Procep, a media that does not stand the pumps too well, it will not damage the bead. So this way, we are very gentle to the media itself. It never sees a pump. So now the top adapter is going to rise until it is at the height that corresponds to the volume of slurry we want to load into the column. So it's going to take 5 to 10 minutes. And as you can see, there is nothing I can do. I can dance if you want, or do something else, but you know, I'm almost useless. So that's the advantage of that column. Anyone can pack it. When you have designed the first process, the first program for the packing, anyone can pack the column. The only thing that has to be done very carefully is the slurry concentration, that's all.
Yeah. Do you want to give a minute for questions or later?
What?
Do you want to give a minute for the audience for a question or later?
Oh, I think later. Or maybe. Is there maybe, do you want to ask any question until to now? Have you understand everything, or is there something you would like to have a better understanding? Is there any questions until now from your side? Okay.
In chat. If can anyone ask that we hear him? Okay.
So you can see that the activity that the user has is only an activity of control to check that everything goes well. What you have to understand is that if something fails into the method, still you can hand the packing manually. So you still have the capacity of handing the packing you are driving in manual mode on the Unicorn system, which means that whatever happens, your packing will be good at the end.
That's them.
Okay, so now we have loaded the media into the column, the media that is needed for the packing. So now what it's going to ask you is to rinse the line. So it's now rinsing the line of the media. So it's getting through that rinse inlet, rinsing back to the tank here, and we'll bring back the media that is left into the tank, back to the pipe back to the tank. So So it's asking you to close the slurry tank valve and then press continue. When I do that, it will start the packing. So now we are starting the packing. So what you can see is that we are moving down the top adapter here at 60 centimeters per hour, and you have here the adapter position. So what you will see here is that you will see the bed forming as we have seen through the slurry tank, as the slurry concentration kit. In 5 minutes, you will see the stabilized bed forming on the bottom of the column, and finally the top adapter will then touch the stabilized bed. From there, it will detect the height of the stabilized bed through that pressure gauge, and when it has detected, it will go on that screen here, and you can adjust your final packing factor according to a variable that could be packing factor or bed height. So now we are under the packing protocol itself.
I'm the one that did the most difficult job, which is the steering.
Yes.
The steering is the most difficult job here, manual steering, unless you have a slurry tank.
Pierre, the valve there is closed.
Yes, I know.
Should we open it?
No.
Okay.
If I need to open it, I will open it. So if you, Shai, if you want to come closer a little bit, if we look at the bed clearly, we can see 3 phases. Here you have the packing buffer that is here. This is slurry under suspension, and this is stabilized bed. So here you can see the stabilized bed. You see that the density is not the same. It's a little bit darker, and the bed will build up until everything is the same density as here, and then the top adapter will touch it and detect the bed. The good news for you is that it is of course better to have an acrylic tube, because you can see what's happening into the bed. But if you wish to have a stainless steel tube, because the detection of the bed is done through that probe, in fact you can have the same results with a stainless steel tube. Even if I think that the stainless steel tube shall only be used when you do blood fractionation purification because of the corrosion of the plasma. That's the only thing. But otherwise, stay with acrylic, but you can use stainless steel and have exactly the same results. And if you look at the screen here, what you can see is that you have the adapter position, so 48.1 centimeter, and the adapter speed, and you also have the pressure within the column that is building up, so 0.18 bar by now. What you can see is that as we pack the column, because we don't use flow, so we don't generate pressure on the bed, the packing pressure is very, very low, which does not mean that your bed will not have a good stability, because at the end we will apply the compression ratio that is needed on the media. What you need to understand is for high flow agarose media, the pressure would be so low that you can never reach pressure that will be relevant for the packing. So that's why we are now focusing on compression ratio, but not on packing pressure anymore. So the identification of a good packing is the compression ratio for that column. In fact, if you look at if you want to come with me, if you the way you know the height of the column is linked to these two cables. Here you have the power cable that is bringing the power into the engine, and here you have a sensor that is counting the number of turns of the engine. And from there, the software of the packing master gives you the height. So you can know the height according to the distance made by the engine. So it's a conversion.
You can also write us questions in the chat. We will try to type them. And also on the chat, yeah. Meanwhile, as Pierre explained, this whole adapter moves down. There is a scale here, as he explained, and ACTA process knows exactly the position of the adapter by the millimeter. Also the master knows it, and it transmits to the ACTA, and we can just have to sit and look at it. Nothing else to do.
Just drink wine, good wine.
Yeah, yes.
Just drink wine.
Yes, you can.
It moves very slowly at a flow rate of
Yeah, that's cool.
60 centimeters per hour.
you see-
Means
It's good to
1
get wine and
centimeter
croissant. It's good to
per
get-
minute,
It's good to get
but it
wine and
moves.
croissant.
It moves.
course, yes.
Shai?
Of course.
Shai, maybe you can approach with the camera. You can see it moves. The scales are going down here on this road. Moving very slowly till the set stage that is set in the program, in the method. As Pierre explained, it moves down until it senses the bed, the settled bed, and then it will start the compression.
So Shai, what you can look at here is that we are seeing the bed building up. So last time when we look at it, it was here. Now it's here, and it will build up until half of it, so around here. So you have about 10 minutes if you want to get a coffee or something. You have plenty of time now to relax until we get to the approach where we touch the bed and start the compression.
Break. See the break?
I think it went a little bit faster than I was expected. Sorry about it, it's my mistake. What we can see is that we have ended up packing. So we had the bed detection at 19.8 centimeter, and applying the packing factor of 1.15, we ended with a bed height of 19.2 centimeter for a theoretical bed height of 19 centimeter. So we have only 2 millimeters of difference between the target bed height that we were expecting and the bed height that we have. So you can see that the slurry concentration measurement was very efficient. It has been working very well. And what you can see if you look at the column also is that now we are starting an equilibration in downflow. And if you look at the column tube, you will not see any more air bubbles because we are removing the air bubbles doing that. So now the column is packed with a bed height of 19.2 centimeters, and we are going to run the compression, the packing test. What you can see here is that it is the packing factor detection, so that you have not seen because I thought that it would take longer. So when you get into there, you say 1.1, 1.12, 1.13, 1.14, until you get to 1.15. And you can choose to stop with the idle compression factor, so 1.15, or if you have a small variation in slurry concentration, then you can decide to stop at the height that you want and have a variability of the packing factor. So you can either way make some variable on packing factor or on final bed height. But you see that if you do your slurry concentration properly, you end with very good results because final bed height is 19.2 with a compression ratio of 1.15. Okay, so we have been going through the equilibration of the bed, and what you can see is that as we have been rehydrating the bed, all the air bubbles have disappeared. So now the bed is totally uniform and can be used in a normal way. And that's it. Let me know when.
You can start to talk to this camera.
Okay, so we are now under equilibration of the column. The speed is quite slow, it's 60 centimeters per hour. So after that, we will run the test at 30 centimeters per hour. It means that we have a break to make the injection on the column that is about 1 hour. So it's now 11.12, and I would suggest that we come back at 12:30, 12:15, 12:30 to see the peaks on the column. Once more, with the method on the Unicorn, everything is fully automated, so there is nothing to be done, which means that only one person can take care of all what we have been doing, and even though you see nothing, we have nothing to do, so just to check after. So make a break for 1 hour and call back at 12:30. So hello again. We are back to the packing of AxiChrom. Sorry for the break, but as we were running the method, testing method, there is no need to stay in front of the computer. So I'd rather have you get a small maybe coffee or things to eat and come back when the column is tested. So we have now our results. What we can see here that we have an asymmetry of 1.19 with 6,300 plates. So it's a plate height of 0.01 as a result. So you can see that the full automated method went perfectly well. The only key of that success is the slurry concentration. So if you do your slurry concentration right, then you will hand systematically with that kind of results. So the AxiChrom packing is very, very simple. Even if you don't know about column packing, you can do it by yourself as everything is pre-written into the method. As you can see also on the column, there is no more air. So we have removed the air by making an upflow on the column tube. So the column is now ready to go and to process for the future. Thank you. I think that's all. We will hand that I would say show, and I would like to thank everyone, Sari who has helped us, and all the people who have been doing the movie. So we hand like that. Thank you.
Thank you. Maybe if someone at the audience has questions now, we can answer general questions.
I wanted to say that we appreciate your presentation and thank you very much.
Thank you for
Thank you.
for participation.
Yes, also thank you very much. And I wanted to ask a question. Can you show us the symmetry and the theoretical plates?
Yes?
Yes, אתה יכול לעשות זום על המסך? This is the pack test result. Here. זום על זה. שני אלה. It's a very strict conditions for packing tests done at 30 centimeters per hour flow rate. Very strict for this very large column, and we got very good results. Normally, more than 3,000 plates per meter is excellent. We got more than twice than this.
Okay, thank you.
Thank you for the presentation and for the option that you show us how easy to pack the column. Complete solution to use. What happened to you? And maybe you can explain a little bit.
I think we're done.
Safi?
כן.
Yeah. First, thank you very much for showing us how to pack the column. Thank you to you, and I'm here. Now we are discussing here about how to do the HTTP and what is the recommendation regarding which solution to use, the volume needed to use, and any other tips that you can bring down to get this nice result.
Yes.
Pierre? Did you hear Luli's question? Luli's asking which solution do you recommend to use for packing test and which volume?
I would say maybe I will go back in front of the column. For the packing test, we are recommending to use salt because, of course, acetone is a much better tracer in water. It's easy to read, but if you place yourself in front of an FDA point of view, they will ask you to prove that you have removed all the acetone from the column, which is very difficult to do. So, because you have to measure the volume in and volume out. So, more and more today, we are using salt. We are using a solution as elution buffer of 0.4 molar NaCl. And then as a test solution, we are using 0.81 molar salt, and we inject 1 or 2% of the column volume. So that's why the industry is going to now, because this NaCl is something you can find in any process, so you don't need to document, I would say, the use of this product is already normally into your process. So we know we are now using salt for column testing. And also I would like I would like to say also that the test is very important, the test speed. You have several solutions to test your column. Either way, you test it at the speed of your process. So it will give you the reality of your process, but it's better to test it at the speed that corresponds to the bit size. So you have some speed according to the bit size that you should keep, and if not, if you go too fast, you may have some interference with the flow. So if you have an asymmetry that is a little high, because you are going too fast, you may not see it. So my recommendation is to test in salt at a speed that corresponds to the bit size. And that's it.
Thank you. Now, standard results are very good. But in case that the result will be not according to expectation, what you can mention to.
Okay, I'll repeat Luli's question. What we can infer from the packing result test if the results aren't good? Meaning, if you have a symmetry of larger than the limit, what does it mean? If you have two less plates, what does it mean? Pierre, can you elaborate a bit?
Yeah.
Overcompression, undercompression, and
It's a little bit complicated, but yes, I can talk about it. Usually, there are two factors that you will look at. The asymmetry factors gives you the dilution of the column. So it means that it will show you how much dilution you can have in a column, but not only in the column, also on the system. So it's measuring the dilution of your installation, including the testing system and the column itself. And then the HTTP will give you the resolution of the column, so the efficiency of the column. It's the void volume between the beads that is calculated with the resolution with the HTTP. So if you have too much dilution, so a bad asymmetry that would be bigger than 1.8, it means that either way your column is not compressed enough, so you are missing compression ratio on your bed, or it means that you have a big dilution on your installation to do the test. Then if your HTTP value is high, it means that your beads are not compressed enough, so the void volume between the beads is too high. For example, if you have an hydrophobic media that you pack into water, you will have hydrophobicity between the beads, so the void volume will be very high. So the resolution of the column will be low. That's why you have to pack hydrophobic media into ethanol. So each media has its own packing solution, but most of the time, if you use salt, 0.4 molar salt, you will get very good results. So that's my recommendation. Only for hydrophobic media you need to have ethanol.
Question is, if there's something wrong with the packing, the asymmetry is not good, and as you mentioned, there is that the packing is not good enough, we need more compression. Should we start all over again from the beginning, or can we continue compression? What would be the reaction
So if you are missing compression, then it could be very simple. If you want to come here, Shai, you can use the manual control of the column. So you have the same on the Unicorn, but here you find all the information that you have. So you will, let's say you are missing compression. You can either way jog down using that button here. So jog down, it will make the top adapter move down, and you will increase the compression as much as you want. You can read the position of the column here, and so it's 19.2 now. So if I jog down, I will go 90.1, 90. You can increase the compression until you get the right compression ratio. Or you can set up a point. So now you are 19.2. Let's say you want to go to 18. You will set 18 here and 60 centimeters per hour to go down, and you just press go to, and that's it. So it's very simple. You can hand or improve your column packing with that kind of tool. But usually when you use AxiChrom, if the slurry concentration is made properly, you will never fail a packing. It's not possible. So it's only slurry concentration that may cause you a problem if it's not made properly, and that's it.
The other way around it works. If it's too compressed, can I just manually dump?
sorry, the question was if it's too compressed, can we just take the plunger up a little bit, or should we start all over again?
Another compression is something more difficult to handle. What you can do is to, if you are a little bit over compressed, so if you have an asymmetry of 0.7 instead of 0.8, what you can do is set up an upflow at 90 centimeters per hour and then move up your top adapter at 60 centimeters per hour. So it will let the bed increase a little bit and regain some asymmetry factors. But then you have to equilibrate the column because you will have disturbed the density of the bed. So you can move up the top adapter once more, having 90 centimeters per hour upflow with the pump and 60 centimeters per hour with the top engine. And when you are done, you make 4 columns volume of equilibration at 90 centimeters per hour to restore the density of the bed. And normally, if it's a media like which is the Capto or a fast flow media, you will regain the bed. If it's a hard resin, you will have to unpack.
Yeah, maybe you can talk about a little bit. Some of the people here and also online has different columns than AxiChrom. And maybe you can discuss about the BPG column, for example. Maybe you can share about the column packing, which can be in a different way with the BPG, and also the differences of using different media on different columns.
So what you are saying, sorry, can you repeat the beginning of the question because I did not hear it?
Yes, it was regarding the packing of BPG or other columns.
Okay.
The AxiChrom method, I would say.
So,
manually, it's possible, and basically the advantages or disadvantages, the differences between the different columns.
So only for the BPG, it is possible to pack a BPG as you would do with an AxiChrom. So you set up a flow at 60 centimeters per hour, then you move the top adapter down, and then finally you measure the compression ratio according to the stabilized bed, and you apply the compression ratio that you need. It is a possibility, so it will train you how to pack the AxiChrom, but it's not as easy as it could be with an AxiChrom. So you need to understand that when you go BPG, it's manual, and you need to make calculation, you need to apply the right compression ratio, move down the top adapter. It's feasible, but it's much better to go straight to AxiChrom, honestly speaking, because then you can upgrade your method from 5 centimeters to 2 meters with exactly the same way of packing. So I think it makes more sense. If we look at other columns, you will find the ChromaFlow, which is the column that was made for the fast flow media. So it's a column that is already quite old, it's 20 years old. And we know that our competitors, Sartorius, have been trying to copy our AxiChrom with this column, but it doesn't work at all the same. It's much more complicated. And what is very important is that you have cones into their columns. So it will generate some density difference within the cones that makes that the results will never be as good as what you get with an AxiChrom. The thing is that with these column, so the ChromaFlow Resolute type of column, you are supposed to pack with flow packing at a speed that maximum is 600 centimeters per hour. If you want to pack a Capto or a MMC media or a map select media, you will need to achieve 1,000 to 1,500 centimeters per hour. So on a column of 60 centimeters, we are already talking about 2,800 liters per hour. So it's 2.8 cubic meter as a flow. If something goes wrong, it's very easy to break the column and wound someone. So that's the reason why when you want to go to high flow agarose, to that kind of media that wants to have high flow, we highly recommend that you move from flow packing to axial compression packing. As you have seen, the axial compression packing is very smooth, very slow, very comfortable. One person can pack the whole column by himself. So and one person that does not know how to pack column. In my case, I've been doing column packing for 20 years all over the world using all kinds of columns. And I know when I go on a customer place now that I set up an AxiChrom with a method for a given media, I know that the column will always work. They will only call me back when sometimes they have a problem like a blockness or something that does not work right on the cleaning of the column. But the columns are so secure and so efficient that once it has been established and well set into Unicorn, there is no need to modify it anymore. So it's a real plus for the users, it's a real plus for documentation for the company that wants to go to FDA production. I think it's really a tool of the future.
Thank you. Any further questions? Okay. Yeah, with that, thank you so much for this opportunity, and also everyone over there. And I hope we can have something like that soon again in Israel.
Yeah, with pleasure.
Thank you very much. Thank you very much, everyone, for joining us online and here in the office. It was a pleasure.
Okay.
Thank you.
Thank you very much. Goodbye. Bye.
Thank you. Bye.
Bye.
Thank you.